Greetings of the day. Welcome to this video lecture. So this video comprises of the mathematical formulation of linear programming problems. Okay. Uh, Content of this is definition of linear programming problem, general form of linear programming problem, canonical form of linear programming problem, and how to find a mathematical formulation by an example problem. Okay. So the basic definitions are linear programming problems. Linear programming problems deals with determining optimal allocations of limited resources to meet given objectives. The resources may be in the form of men, raw materials, market demand, money and machines, etc. Usually the objective is to maximize the profit or minimize the cost. LPP deal with optimization. According to the situation, this means maximization or minimization of a function of decision variables. These variables are the values to determine the solution of the problem, known as objective function. Subject to a set of simultaneous linear equations or inequations known as constraints. The term linear means that all the variables occurring in the objective function and the constraints are of the first degree, and the term programming means nothing but the process of determining a particular course of action. The general form of LPP is as follows. Optimize. According to, we use either maximize or minimize. Optimize is equal to C1x1 plus C2x2 plus and so on plus Cnxn, subject to the constraints AI1 x1 plus AI2 x2 plus and so on plus AIN xn, either greater than or equal to or equal to or less than or equal to bi, where I varies from 1 to small letter m, and the variables involved in these x1, x2 and so on xn are all positive nature. Being a solution, we can't find negative values of the variables. The canonical form. The canonical form is nothing but maximize instead of optimize. In the general case, we use maximize. The term maximize. Maximize is equal to C1x1 plus C2x2 plus and so on plus Cnxn, subject to the constraints AI1 x1 plus and so on plus AIN xn. I gave you in the previous general form either greater than or equal to or less than or equal to or equal to. So in the standard form or canonical form, we use only less than or equal to bi, where I from 1 to m, and as usual non-negative variables x1, x2 and so on xn are greater than or equal to 0. So let me go with an example first of all before going to the step-by-step procedure of finding mathematical formulation. I gave an example first and then go back to the procedure. So consider the following problem. A manufacturing firm of two types of products X and Y and sells them at a profit of ₹2 on X and ₹3 on Y. Each product is processed in two machines M and N. The type X requires a minute of process on time machine M and 2 minutes of processing time on N. Similarly, type Y requires a minute on both M and N. The machine M is available for not more than 6 hours, whereas N is available for 100 hours during any working day. So how will you formulate this problem as a mathematical model by using linear programming problem? Let us see. The decision variables. So here you are given the two types of products. So the decision variables are x1 and x2. So the x1 and x2 be the decision variables, number of units produced for the two types x and y respectively. What are the data given here? So column heading M and N, row heading products. So x and y, x1 and x2 we use. So x goes 1 minute process on M and 1 minute process on N, that's why it's 1 and y goes 2 minutes process on M and 1 minute process on N, so 2 The profit of the two products x and y are given under the last row of the table. So X has the profit selling price 2 and Y is selling price 3. So availability is nothing but your conditions. So M is not more than 6 hours, N is 10 hours. Not more than 6 hours means you cannot use more than 6 hours. So either up to 10 hours you can use. Okay. So processing are given in time unit as minute, whereas availability is given in hours. So you have to convert the availability or duration into minutes. So it's not more than 6 hours means 6 hours can be converted as minutes. 6 into 60, that is equal to 360 minutes, and 10 hours is nothing but over 600 minutes. Okay. So here you have the profit function is z equal to 2x1 plus 3x2 subject to the constraints x1 plus x2 less than or equal to 60 and x1 plus x2 equal to 600. Typographical error here. Instead of 400 replace with 600. So the production of negative number of units is meaningless, so that we have x1 x2 are greater than or equal to 0. So this is what our mathematical formulation of the problem. So let us go with your procedure. What is the procedure here? Step by step procedure to find your formulation. So first of all, you have to write in the first step the decision variables of the problem. Second step, what is the objective function you have to formulate, whether it may be maximized or minimized. Next one is the constraints. So formulate the constraints of the problems as your resource limitations are market constraints, interrelation between variables, etc. as linear equations or inequations in terms of decision variables. Finally, you add the non-negative constraints from the consideration that negative values do not have any valid physical interpretation. So the objective function, set of constraints, and the non-negative constraints together form a LPP. This is what the mathematical formulation of an LPP. So thank you so much. See you again.